Hello everyone, welcome to my channel Chemical Engineering Knowledge. This lecture we will discuss the multiple choice question of chemical reaction engineering. So let's start. From Arrhenius law is the temperature increases dash increases. So from the Arrhenius law, what is the Arrhenius law? It is K is equal to K naught e to the power minus E by RT. This is Arrhenius law. So from this law as the temperature increases, the rate constant increases. And as the rate constant increases, the rate of chemical reaction will also increases. So as the temperature increases, the rate constant increases, and as the rate constant increases, the rate of reaction also increases because rate is nothing but it is Kca. So if rate constant increasing, the rate will also increases. From Arrhenius law, as the activation energy increases, the slope of the line dash from below figure, from this figure A, will increases, it will be decreases. So from Arrhenius law, as the activation energy increase, the slope of the line from the figure below will increase or it will be decreased. So as the activation energy increases, as this activation energy increases, this slope will be increases also. As the activation energy increases, as the activation energy decreases, the slope will decrease. As the activation energy increases, the slope E by R will be increases on. So as the activation energy increases, the slope of the line will increase. Will increase. From every For every 10-degree increase in temperature, the rate of reaction become double. This work only at low temperature, room temperature both. So for every 10 degree the rate of chemical reaction become doubles. This work only at low temperature, or it can work at room temperature. Yes, both A and B. It work at low temperature, not at higher temperature. From figure A, from figure A, we conclude that reaction with higher activation energy are very temperature sensitive. From this figure, we conclude that reaction with high activation energy. So this reaction is high activation energy as compared to this reaction. So are very sensitive, are very temperature sensitive. As the activation, we conclude that the reaction with high activation energy are very temperature sensitive, while reaction with low activation energy are less dash sensitive. So reaction with high activation energy, this reaction is high activation energy as compared to this reaction. So this reaction is very temperature sensitive as compared to this one reaction. So the low activation energy are relatively less temperature sensitive concentration both non. So reaction with high activation energy are very temperature sensitive, while reaction with low activation energy are less temperature sensitive. So temperature is the correct option. So what is X and Y is in this reaction? Te is the energy of reactant. Energy of reactant. This is the energy of reactant. It is the threshold energy. Te is the threshold energy or energy of the reactant. Ea is the activation energy. Energy to molecule of gas. So threshold energy minus energy of reactant molecule is equal to activation energy to the molecule. So this is a relation, just ignore at this time. So what is X and Y? X is the activation energy. This is the energy of reactant molecule at the start. When we give it some energy to reach it to some high energy, then this energy is called the threshold energy, and this X is the activation energy which we give to our reactant molecule to form the activated complex, and then from activated complex it will form the product. So X is the activation energy while Y is the threshold energy. This is the threshold energy, this one is the threshold energy, and this X is the activation energy. So threshold energy minus activation energy. So threshold energy minus energy of the reactant molecule. This is the threshold energy, and this is the energy of the reactant molecule. This one energy of the reactant molecule, and this one is the threshold energy. So threshold energy minus this energy it will give us this energy, which is nothing but the activation energy is from this relation. So in this figure, x is the activation energy and y is the threshold energy. Yes, this one is correct. X is the y is activation energy, x is the activation, y is the activation energy, while x is also the activation energy. This is wrong. X plus y is the threshold energy. Yes, x plus y when combined it gives threshold energy, which is the maximum energy attained by the molecule. Both A and C, yes, both A and C are the correct option. So X plus Y are the activation, are the threshold energy, while X is the activation, while X is the activation energy, and Y is the energy of the reactant molecule. So according to the collision theory, only dash collision of reactant molecule will give us product. So only collision, no. Effective collision, yes. So both collision and effective collision and also correct orientation will give us product. So both collision, both A and B are the correct option. So both collision and effective collision. So not only collision, but this is the correct answer. Effective collision will give us the product, but not only effective, but when molecules are in correct orientation, that it will only give us the product. So molecule with effective collision and when combined with correct orientation, it will give us the product. Otherwise they will not give us the product. Which one of the following is the correct orientation of molecule to produce the product? So from collision theory we know that the molecule should be combined in correct orientation. So A C plus BD, C combined with BD, it gives us B and CD. So this is C, this is B and D. So B and C, this is C and this is BD. The C coming toward the B and D. The C is coming to the D, is coming toward the D. B is coming toward D. So C and D, this one, C and D must be in correct direction, in the correct orientation. So when C molecule come toward this molecule in the correct orientation, like in this direction, this, and in this direction, this is. So in this case, the C and D are in the correct orientation, then they will give us product. In this case, C and D will one product and B will be the other product. So this one is the correct option according to collision theory. Proper orientation of molecule with effective collision per molecule is must to produce the product. Otherwise, no product will produce. This is the collision theory. According to transition state theory, activated complex is formed. And what is activated complex? It is the product, it is the reactant, it is a state where reactant bonds are breaking and product bond are forming at the same time. It is a state where reactant molecule, the bond between reactant molecule are breaking and at the same time bond between product molecule are forming. This is the correct. This figure shows us many reaction. This is activated complex, this is another activated complex, this is another, this is the reactant, this is the activated complex, this is the product, again this is activated complex, this is the product, again this is activated, and this is the product. So this reaction occur in 3 steps. In the above graph for multiple reaction, which step is the rate determined step? So this step is the rate determined step because the activation energy of this step is very high. So step number 1 is the rate determined step, and this step is the fastest step. Which step is passed in the above figure B? Step number 3 is the fastest, and this is the slowest step, which is the rate determined step, is step 1. Figure A. A is the exothermic reaction. Figure A is the exothermic reaction. Figure B is the endothermic reaction. Figure A and B are correct. Both A and B are correct. B show exothermic while A show the endothermic reaction. So this delta is negative. It shows the exothermic reaction. Energy is releasing. Here energy is absorbing. Energy of the product is larger is the energy of reactant. Here energy of the product is less than energy of the reactant. So this is the exothermic reaction. This shows the endothermic reaction. So both A and B are the correct option. Yes, this is the exothermic. This is the endothermic. Both are correct. The energy of transition is dashed in reactant molecule and product molecule. The energy of transition state or activated complex is larger than, is more than the energy of reactant molecule and energy of the product molecule. So at the transition state, the energy is maximum. Like at this state, the energy is maximum. Here energy is minimum. Here energy is minimum. So more is the correct option. According to transition state theory, the reactant and product molecule are in equilibrium, past equilibrium, both. According to transition state theory, the reactant and product molecule are in equilibrium. So are in equilibrium, past equilibrium. None of them. According to transition state theory, the reactant molecule and the activated complex molecule will be in equilibrium. So none of them. This is A and B. This is the activated complex. This gives the product. AB is called the transition state activated complex. Transition state activated complex. None of them. Both. So both. This is also called the transition state. This state is the transition state, or it is also called the activated complex state. Delta G is equal to minus H is equal to delta H minus Ts. H is the enthalpy change. This is the entropy change. This is the absolute temperature. This is the, what is this delta G? In this relation, delta G is Gibbs free energy, Helmholtz energy, kinetic energy, energy equivalent to work, energy available to do work, both A and D. So this is the Gibbs energy. And what is Gibbs energy? Gibbs energy is nothing but it is the energy available to do work, some useful work. So both A and D is the correct option. So this was all about the chemical reaction engineering. Thank you very much.